Hello everyone, and welcome to this video. Today we'll dive into Python code using Google Colab to understand histograms. Histograms are a great way to visualize the distribution of data. If you're new to Colab, head over to the Colab website, https://colab.research, google.com. It's a free cloud environment where you can run Python code without installing anything on your computer. Just sign in with your Google account and you're good to go. Importing libraries. Alright, let's jump into the code. The first two lines. Import numpy as np. Import matplotlib.pyplot as plt. These lines import two important libraries we'll use. Numpy, number.py, is a powerful library for working with numbers in Python. Matplotlib.pyplot, usually abbreviated as plt, is a library for creating visualizations like charts and graphs. Generating random data. Next we have this line. Data equals input@random.ran1000. This line generates random numbers using number.py. The random function creates numbers from a standard normal distribution, which is a bell-shaped curve you might have seen in statistics. We're setting the size to 1000, so we'll have 1000 random data points. Creating the histogram. Now comes the fun part, creating the histogram. Here's the code block. Let's break this down step by step. plt at figure, fig size satface 8, 6. This line creates a new figure for our plot. We're setting the size to be 8 inches wide and 6 inches tall. You can adjust these values if you prefer a different size. plt at hist, data, bins equals 30, color equals sky blue, alpha equals 0.7. This is the key line for creating the histogram. Here plt.hist is the function for plotting histograms. We pass in our data as the first argument. The bins argument specifies how many bars we want in our histogram. Here we're using 30 bins. You can experiment with different numbers of bins to see how it affects the visualization. The color argument sets the color of the bars to sky blue. Finally, alpha equals 0.7 makes the bars slightly transparent, allowing us to see some overlap if the data points are clustered. plt.title, histogram of random data. This line adds a title to our plot, describing what the histogram represents. plt.label, values. This line labels the x-axis, indicating what the values on that axis represent, the data points. plt.alabel, frequency. This line labels the y-axis, indicating what the values on that axis represent, how often each data point value appears. plt.grid true. This line adds grid lines to the plot, making it easier to read the values. Running the code in Colab. Now that we've explained the code, switch back to your Colab notebook. Click on the Run button triangle symbol next to the code cell, or press Shift plus Enter. This will execute the code and generate the histogram. Explanation of the histogram. The histogram you see visualizes the distribution of the 1000 random data points we generated. The x-axis represents the range of values, and the y-axis represents the frequency of each value. The height of each bar shows how many data points fall within a specific range. In this video, we explored how to use Python libraries in Colab to generate random data and create a histogram to visualize its distribution. Histograms are a valuable tool for understanding the spread of your data. Feel free to experiment with different datasets and adjust the code to see how the histograms change. Thanks for watching.